The strategy pattern is the most useful design pattern in real-world code. If you learn one pattern, learn this one. Every codebase I have worked on uses it. Strategy pattern. Low-level design, day 5. Let me start with the problem. You have a function that calculates discounted prices. It takes an item and a discount type. Inside, there's an if-else chain. If the type is flat, subtract 100. If it is percent, multiply by 0.8. If it is buy one get one, multiply by 0.5. If it is seasonal, multiply by 0.7. Every time the business adds a new discount type, you have to modify this function. The function grows to 200 lines of if-else statements. It violates open-closed because you are modifying existing code for every new type. It is untestable because you cannot test one discount in isolation. And it is a maintenance nightmare because every developer touching this function risks breaking other discount types. The strategy pattern solves this elegantly. It has 3 parts. First, the strategy interface. This defines the algorithm signature. In our case, it is a discount strategy interface with an apply method that takes a price and returns a discounted price. Second, concrete strategies. Each discount type is its own struct that implements the interface. Flat discount subtracts a fixed amount. Percent discount multiplies by a percentage. BOGO discount halves the price. Each strategy is independent and testable in isolation. Third, the context. This is the class that uses the strategy. Our pricing engine holds a reference to a discount strategy. It calls the strategy's apply method without knowing which concrete strategy it is using. You can swap strategies at runtime by changing what the context holds. Here is the code. Define the discount strategy interface with an apply method that takes a price and returns a float. Flat discount has an amount field. Its apply method returns price minus amount. Percent discount has a PCT field. Its apply method returns price times 1 minus the percentage divided by 100. The pricing engine struct holds a discount strategy reference. It has a set strategy method to swap strategies at runtime, and a calculate method that delegates to the strategy. Now adding a new discount type means creating a new struct. 0 changes to pricing engine, 0 changes to existing strategies. Pure open-close principle applied to the strategy pattern. Strategy pattern is everywhere in production code. First, payment processing. Every payment gateway checkout page uses it. Payment strategy interface with credit card, UPI, PayPal, and crypto implementations. The checkout page swaps the strategy based on what the user selects. Second, authentication. Auth strategy interface with OAuth, JWT, API key, and SAML implementations. The same login flow, but different authentication mechanisms behind the interface. Third, compression. Compression strategy with gzip, Brotli, and ZSTD implementations. A file uploader picks the strategy based on file type and size. Fourth, notifications. Notify strategy with email, SMS, push, and Slack. User preferences determine which strategy runs at runtime. People often confuse strategy with factory and state patterns. Here's the difference. Strategy versus factory. Strategy is about how to do something. It picks the algorithm at runtime. The client explicitly sets which strategy to use. Factory is about what to create. It creates objects based on a type. The factory decides which class to instantiate. Interestingly, they often work together. A factory can create the right strategy based on some input. Strategy versus state. With strategy, the client explicitly swaps the algorithm. Strategies are independent of each other. With state, behavior changes based on internal state transitions. States know about each other because they define which state comes next. The key question is, who triggers the switch? If the client triggers it, it is strategy. If the object's internal state triggers it, it is state. When to use strategy pattern? When you have multiple algorithms for the same task. When algorithms need to change at runtime. When you see a growing if-else or switch chain. When you want to test algorithms in isolation. Red flags that scream use strategy. A switch statement on type with multiple cases. an if-else chain that checks a type string, a function that has over 100 lines of branching. Common interview questions. Design a pricing system. Answer with discount strategy interface, pricing engine context. Design a sorting library. Sort strategy with quicksort and merge sort, picking based on data size. Design a notification system. Notify strategy with email, SMS, push. User preference sets the strategy. The pro tip is to show the if-else mess first in the interview, then refactor to strategy. It demonstrates you understand both the problem and the solution. 5 things to remember. The strategy pattern encapsulates algorithms behind an interface and lets you swap them at runtime. A growing if-else or switch chain is a code smell that should be refactored to strategy. The structure is context has a strategy interface, concrete strategies implement it. Strategy is about how, factory is about what, and state is about internal transitions. And in interviews, always show the bad if-else version first, then refactor with strategy to demonstrate you understand the why.